A Kelvin wave is pushing east. A westerly wind burst is forecast. OMG! I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, January 11th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Sorry for the over-the-top intro. I just couldn't help myself. There is actually some good news. Anyway, if you'd like to subscribe, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you'd like to leave a comment or question, do so below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks donated last week. Tim Caston, B. Nadine, Evolution Moto, Evan Thomas, O'Dillard, Craig, Basilke, and then our big contributors for the week, Leona Roberts and Tucker Wooding, twice. Thanks, Tucker. I owe you a beer. All right, with that, let's get to work. We'll start by taking a look at significant wave heights around the planet. Starting in the North Pacific, yeah, we have a bit of activity, an area of seas in the 25-foot range off the Pacific Northwest, another area of 25-foot seas targeting Hawaii, another area of 28-foot seas. Oh, nope, 26 or 27-foot seas off of Japan. In the South Pacific, there's actually an area of 24, 25-foot seas off of New Zealand. Up to the North Pacific, another couple of areas of 22, 24-foot seas scattered there. South Atlantic, pretty quiet. And then in the Indian Ocean, the biggest seas on the planet, 28.9 feet. Right there, south of Madagascar. These are the highest seas on any of these charts. Down on the bottom, their location, max winds over the entire domain. That is the area depicted in the chart. But let's start by taking a look at current conditions. We're going to look at the buoys, starting up in the Pacific Northwest. Grays Harbor Buoy, 036, right on the border there between North Oregon and South Washington. We're looking at all the energy that's hitting that buoy all the way from up to 33.3 second period. That's very long period energy. We actually have 0.2 of a foot of energy there, all the way down to 5 second period. That'd be just pure wind chop, not really even rideable. We look for the highest spot anywhere along the graph. We see 4.5 feet of energy at 16.7 seconds. That does not comprise all the energy in the swell. The energy also is what is on the shoulder on either sides, but clearly there is some sort of a swell in the 16.7 second period range. Primary swell, we have an algorithm that sort of calculates it for us. 6.6 feet at 16.1 seconds from 269 degrees, making surf theoretically at 10.6 feet at your normal beach break sort of thing without any swell enhancing bathymetry. That would be some sort of reef that can magnify the swell size. Secondary swell, 6.2 feet at 10.2 seconds from 236 degrees, and that would put like 6.4 feet of probably lump on top of the swell or intermixed with it. Heading down to San Francisco, Ocean Beach area, buoy 46026. We'll see the very beginnings of that same swell starting to read on the buoy, 1.8 feet at 18.9 seconds there. But you can see primary swell, 2.6 feet at 19.2 seconds from 289 degrees. That theoretically would put surf at 5.1 feet. And then background energy, 2.1 feet at 11.5 seconds from 288 degrees. Surf or bump again in the mix, 2.4 feet. Down to San Diego, California, the Point Loma South buoy, 191 there off of San Diego. Pretty much nothing happening there, but some of this energy that's hitting in Northern California and up into Oregon is expected to reach eventually down into Southern California. Right now, peak energy just eyeballing at about 13.3 seconds. The algorithm, tells us 1 foot, 13.3 seconds from 242 degrees. That would put surf at 1.3 feet, and then some Secondary random swell, 0.8 feet at 9.8 seconds from 255 degrees, and you're talking less than a foot of surf. And then over to the Waimea Bay buoy, north shore of Oahu, buoy number 106. We have the same swell that's starting to show in the Pacific Northwest and Northern California, still present in Hawaii. Peak energy, just eyeballing it, maybe 15.5 or 6 seconds, something like that. Let's go take a look. 6.3 feet at 15.7 seconds from 339 degrees, making surf at 9.8 feet. With some secondary energy in there, 6.2 feet at 12.6 seconds from 333 degrees. Another 7.8 seconds, just eyeballing that, 12 seconds, almost thinking that's all part of the same swell hitting at the same time. All right, so what's been going on for the past week? Actually, 10 days. The last video we did was on Friday, about 10 days ago, so we'll do a rewind back that far. We had a little bit of a gale that tried to flare up there off of California. Mainly produced weather, rain, snow up in the Sierra. This was on Sunday. Another gale developed while pushing north to the North Dateline region. Seas got up to 44 feet. Yep, right there. This was on Sunday night, the 4th of January, a week ago. That swell has already come and gone. I think it pushed into Northern California on Friday. Secondary energy from it pushed into the Gulf. All that swell has come and gone as well. Then we had another gale. This is what is really the main focus right now. It started on Thursday, the 8th of January, with 32-foot seas building to, I think we got 34 feet right there. This was early on Friday, the 9th of January. 35 feet, there we go. This is a swell that is currently hitting Hawaii, and the early bits of it starting to show into Northern California. We can actually run this out to Sunday. You see on Saturday, there was still energy at almost 29 feet in the northern Gulf of Alaska. New gale developed right behind that on Saturday with 34-foot seas falling southeast. And there we are currently, that next swell poised for Hawaii. Currently, you see the swell front off of Northern California already hitting the Pacific Northwest. So a bit of energy, this second system more targeting Hawaii than Northern California. To the South Pacific, again, going back to Friday, we'll put this in motion. The expectation, given the time of year, is not a whole lot is going to happen, though we did see a little something there off of New Zealand. Just look at that. There is 30-foot seas, but notice all the vectors pushing to the southeast, so no swell to result from that. Here we are, this little system, 30-foot seas, quickly faded. All the energy pushing east, if not southeast. I'd say odds are very low. Maybe the South Shore of the Hawaiian Islands will pick up a little background energy from this, but not a significant swell-producing event. Over to the North Atlantic. Back on Friday, the 3rd of January, not a whole lot was going on, but you can't really see it here. Yeah, a little gale south of Greenland. That was on Tuesday, the 6th of January. See what else? A little bit of a system here on Thursday, Friday, pushed into, I guess that's the English Channel. Pretty rare to squeeze something with 30-foot seas in there. Probably pretty rare swell direction, too. I'm sort of hesitating when I talk because I've cheated and looked at the forecast moving forward, and things look much more positive for the North Atlantic, but we're not quite there yet. To the South Atlantic, again, we're back about 10 days ago. A little system with 22-foot, 24-foot seas passed south of South Africa. That didn't do a whole lot. Then you get this local gale on Tuesday, Wednesday, the 7th of January, that produced 25-foot seas right there, the highest seas. Oops, where we go? There we go. And maybe a hair bit more. That resulted in raw swell for exposed breaks in South Africa. Then another system on Friday has developed with 36-foot seas, building to 43 feet, 42 feet, and we're into Saturday. Sunday, you can see a bit of a swell front right here pushing in. Oops, and there we were at current time right there. So it looks like some sort of a swell is poised for South Africa and kind of out of the ordinary for season-wise. And then finally, the Indian Ocean, going back 10 days, we're in motion. A little bit of a gale produced 24, maybe 25-foot seas that targeted mainly Western Australia. Tropical system there, you see that. There's the system that pushed under South Africa. Just looking for anything. We're into Friday. What was that? Let's go back just a little bit. 26-foot seas, pretty good distance away and not aimed very well to the northeast, but still maybe sideband energy into Western Australia to result from that. And here we are, current time, something south of Africa. Unknown what's going to happen to it in the future, but we're going to find out. So what does the future hold? And we're going to do a deep dive into the North Pacific. We're going to start by looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a push in the jet to the south. We clearly see that right here. And what that helps do is create a counterclockwise flow aloft, an eddy in the upper atmosphere. That also manifests itself down at the ocean surface. That is the hallmark of low pressure, that counterclockwise circulation. And if the low pressure is strong enough, it generates winds. Those winds get traction on the ocean surface, generating seas. As those seas radiate away from the fetch area, the lesser period elements decay away, exposing longer period swell. And of course, swell when it hits your beach, like in Hawaii or in California here, that results in surf. So we have a pretty consolidated jet stream. Thank goodness. We've been suffering for the past, I don't know, since at least mid-December, if not early December, from a very weak and split jet stream flow, likely due to the inactive phase of the MJO. We'll get into that in a minute, which was generating easterly anomalies down here. That is stronger than normal trades in this area. That typically steals energy from the jet stream. The jet stream gets weak. It falls apart and splits. We don't have that now. We have a reasonably healthy jet stream, 190 knot winds pushing off of Japan, falling into a trough over the dateline, being fed by 170 knot winds. And the split point, you notice it right here at about 140 west. Energy pushing up into British Columbia, splitting, energy pushing into Mexico. But when you get the split in this pattern like this, you get high pressure, dry air. And that is currently what is happening over California and even Oregon for the matter. A drier period is likely setting up. Let's put this into motion. Get into Monday. The trough continues, starting to pinch off a little bit while winds build to 190 knots off Japan. Tuesday, the trough kind of gets pinched off, disintegrates, but winds are still solid, feeding into this area. Split point retrogrades a little bit here to about 150, almost 155 west. How we doing into, with a pinch trough, though, Wednesday night here north of the Hawaiian Islands. Again, likely funneling energy towards the Hawaiian Islands. Then we get into Thursday, Friday. The jet weakens. Look at the split here. Huge split with just a massive high pressure blocking the entire U.S. and Canadian west coast. All energy funneling direct up into Alaska. We're into Friday, Saturday. The jet finally starts trying to rebuild with 190 to almost 200 knot winds and a trough digging out over the dateline. This is on the early part of Sunday. Still that split persists. We need a bit more fuel in the jet stream. I mean, all looking good till about somewhere between 170 and 150, depending on which day you're looking at, but still this huge split pattern over the U.S. West Coast, south, north, and even up into Canada. So let's go take a look down at the ocean surface. It takes winds blowing on the ocean surface to generate swell. This is a chart of surface level pressure and surface level winds. A broad low pressure area here is in the, I'll call it the northwestern Gulf of Alaska, 30 knot winds targeting Hawaii. That could generate some swell. And 30 to 35 knot winds pushing up into Vancouver Island and British Columbia. That could generate sideband swell as far south as, I'll say, San Francisco. And then, of course, a stronger gale, but the only fetch aimed off to the east here, 40 knot, all this 45 knot winds and 50 knot winds is pushing up towards Kamchatka. Put this into motion as we get into Monday. Low pressure generally starts fading here in the Gulf. The low over the Kuril Islands, not looking particularly impressive. Now this sideband, this southerly fetch out here on Monday into Tuesday could generate some sideband swell radiating into, I'll say, central and northern California, but not really a whole lot. Next low really gets firing up on Tuesday, the 13th of January, on the dateline, targeting the Hawaiian Islands with 45, maybe even a tiny area of 50 knot winds, maybe some sideband energy aimed at the U.S. West Coast, but most of the swell, you just look at the vectors, are all aimed directly at Hawaii. That system pushes off to the east. Again, more northerly angle fetch pushing into Hawaii or targeting Hawaii Wednesday night into early Thursday. New low sets up behind that on the dateline. Here you go, 40 knot winds targeting the Hawaiian Islands. Though kind of fragmented, doesn't quite get so organized. We know the jet isn't looking particularly great. Yet another system develops on Saturday with 40 knot winds targeting the Hawaiian Islands over a pretty good size area. It too sort of fragments and splits off. One fetch at the Hawaiian Islands, another one here at the Hawaiian Islands. You notice nothing really seems, as we get past pretty much today, seems to penetrate anywhere east of 160 west. Again, speaking to high pressure, not so much in the lower atmosphere, but in the upper atmosphere. And there we are 180 hours out, as far as one can reasonably expect to believe any kind of a model. So what effect do those winds have on the ocean surface? Well, we see as of right now was that 25-foot seas off the Pacific Northwest, 24 to 25-foot seas targeting Hawaii, and then the other gale off of Japan. We'll put this into motion. So we get into Monday, still 22, 23-foot seas targeting the Hawaiian Islands, but really nothing at the U.S. West Coast, and something trying to organize off the Kuril Islands, but just not really doing it. Here's that little area of sideband fetch. Oh, it's actually seas. Well, let's get it more somewhere in there. Even that's really pushing it for swell into California. This is really probably more the Pacific Northwest with 24-foot seas. We'll put this into motion. Here we go. The next gale starts developing on the dateline, international dateline 180 west. Tiny area of 30 to 31-foot seas, building to 35 feet, falling southeast to some degree. Fetch targeting the Hawaiian Islands. You see swell front right there pushing towards the islands. Secondary fetch developing with 25-foot seas. Again, maybe targeting Hawaii, certainly more than the U.S. West Coast. Looking for any sort of swell energy pushing off to the east into California. You see it only targeting Hawaii. Next gale sets up with 30, 28, and it sort of fades out. You see some energy trying to move east. And yet another system about almost a week out, Saturday, the 17th of January, with 31-foot seas. Again, making it to the dateline, but not a whole lot further than that. U.S. West Coast, not getting a whole lot of swell. The Hawaiian Islands look to be the primary target. To the South Pacific, the little system here east of New Zealand continues off to the east and kind of fades. Again, doubtful any swell result, just given the time of year, just not a great setup. We're into Friday, Saturday. Next system develops, falling hard south into Sunday. Is interesting, 33, was that 34-foot seas, but again, all aimed south, a penguin storm, nothing pushing up into our forecast area. Over to the North Atlantic. So I had sort of hinted at something happening there, and here we go. Tuesday, the 13th of January. Strong system develops, 46-foot seas aimed off to the east, 42 feet as we get into Tuesday night, 36-foot seas Wednesday morning, fading down to 28 feet. This is good for long period swell, pushing right into Ireland right there, and also Portugal in that area. So when we get into the spot forecast. And then secondary energy building behind with seas at, 31 feet. Again, probably more pushing into the Bay of Biscay and Portugal than Ireland. See, we're into Saturday. Another little gale develops. That quickly fades. Sunday, here we go again. Seas in the 35-foot range. Continuing 33 feet. And there we are 180 hours out. Portugal looking good, a bit south of Ireland and into the Bay of Biscay. To the South Atlantic, in motion, looking for anything. There we go, a little bit of 30-foot seas on Tuesday, 13th of January, targeting South Africa. Nothing huge, but you see a swell front pushing into that area. Is there anything behind it? We're out 130, 150 hours. 180 hours. Nope. So one swell producing system forecast for the coming week. And then the Indian Ocean. Looking for anything in the, say, 25 feet or more. Pretty quiet indeed. Oh, there we go. Right when you give up hope. 32-foot seas on early Saturday, building to 34 feet, 35 feet. And Sunday, and actually aimed well to the northeast. This would, if it develops as forecast, and you're kind of out 6, almost 7 days, kind of pushing the model envelope a little bit, but something to monitor. Looks like if it happens, swell certainly for Western Australia up into Bali, Indonesia, Mentawai Island area. Local wind forecast for California here, Hawaii down here. So this would be Southern California, that's Point Conception. Central California, there's Monterey Bay. Northern California, and then, of course, the Hawaiian Islands. High pressure, no big surprise with the split jet stream in control. Probably only going to build, producing a northerly wind pattern on Sunday along most of the coast. Near shore, probably northeast. Hawaiian Islands under southeasterly, I guess I'll call them trades, 10 knots. We get into Monday. This northerly flow continues at 10 knots, maybe 15 knots. For California. Notice the front approaching, if not pushing over the Hawaiian Islands with northwest winds in the 15 to 20 knot range later on Monday. Tuesday, the front fades, winds northeast for the Hawaiian Islands. Again, the north wind pattern, 10 knots for the California coast. Into Wednesday, you see building high pressure right here. A little bit stronger north wind pattern for California. Southeast trades, 10 knots for the Hawaiian Islands. Wednesday, here comes the next front. South winds pretty strong, 15, 20 knots. You get almost a pressure gradient with the high a little bit off the coast. For the Santa Ana type wind deal or an offshore flow, you want the high pushing over the Great Basin here, but because the split in the jet is retrograding off to the wind to the west, then the high pressure pattern starts pushing a little bit more off the coast. Anyway, Wednesday into Thursday, full on pressure gradient, 30 knot north winds. That could push wind swell down into California, and almost you get like a return flow. You can see a hint of southerly winds along the coast. This is Thursday the 15th. You see northwest winds, 15, 20 knots for the Hawaiian Islands. Friday, everything sort of breaks up. Lighter wind regime for California. Northeasterly winds, 15 knots for the Hawaiian Islands. So we get into Saturday, a light flow sets up again for California. Trades 15 knots for the Hawaiian Islands. We're into Sunday, same sort of deal. Light northwest wind pattern, 10 knots for California. Trades 15 knots, some sort of a broad front off the coast here, or pushing off to the north. We'll go 180 hours out. Late on Sunday, early Monday, pretty much no change for California. And southeast winds 15 knots for the Hawaiian Islands. It seems like there is just this wall right along the Pacific Ocean, somewhere around 150 west, right where Hawaii is. That's the separation between the stormy weather and high pressure and a lighter wind regime east of there. Looking at the precip potential for California, okay, you kind of know what to expect already. You can see the isobars stacked up. Now notice the high pressure is a bit inland here. We'll put this into motion. We're just blue is rain for California, and California is this area. We see nothing as we're into Monday, Tuesday, Wednesday. Here comes the high building actually off the coast and lifting north up into Canada. Continued high and dry Thursday, Friday, Saturday, Sunday. We can go out about there into Monday. Look, 1036 millibar high way up here, just completely blocking the pattern. I looked at the models going out 2 weeks, totally not believable. They do show something pushing down about 2 weeks out, but I think that's more fantasy land than anything. The snow forecast dashboard for Olympic Valley, formerly Squaw Valley. Nada, no snow. There is a little thing here on the 21st of January, sort of what I was alluding to, but I don't believe that. And then snow levels or temperatures, if you will. This would be the base of Olympic Valley at 6,200 feet. This is the summit at 9,000 feet. Red would be liquid precipitation if there were any precip. The gray would be sleet. The freeze line, the 32-degree line, is the intersection between the gray and the white right there. And you see this, so the snow level today at 10,500 feet, going to 12,000, going up to 13,000 feet at one point, and still just way above the base of anywhere in Tahoe. And even at Mammoth, the summit is up at 11,000 feet. Above that, literally, it's maybe a good thing there's not going to be any precip because it would just rain on whatever snow is there. If anything, out about a week, maybe we'll be into a corn snow sort of situation. Surf spot forecast for the Columbia River area, northern Oregon. First swell coming in, surf heights 16 to 17 feet. This would be early on Monday, fading down into Tuesday and later Tuesday. A bit of sideband energy. This is my guess from that fetch off the coast. Maybe 14 feet on Wednesday, fading out. And then after that, just in the fun size range, 4 to 5, maybe 6 feet sort of thing. Oh, and actual swell heights, 10 feet at 15 seconds on Monday. Tuesday down to 7 feet at 12 to 13 seconds. Wednesday, a little bit of more energy, 9 feet at 16 seconds. That fading out as we're into the weekend. 3 to 4 feet at 14 seconds. That would be fun size surf for sure. To Ocean Beach, San Francisco, surf heights on Monday, pretty much right at 10 feet, 9 feet sort of thing later in the afternoon, fading into the 6 to 7 foot range on Tuesday and smaller on Wednesday. Secondary pulse of energy on Thursday in the 6.5 foot range. That's surf face heights, not including swell enhancing bathymetry. Friday down to 5 feet, dropping from there. Little bit of energy next Sunday, 5.5 feet. Winds, some flavor of northeast other than on Monday, which is kind of a northeast sort of thing. Swell heights, 6.5 feet at 15 to 16 seconds on Monday. Tuesday, 5.5 feet at 13 seconds. Wednesday, 4 feet at 12 seconds. New energy pushes in, 4.5 feet at 14 seconds on Thursday, heading down from there. And then we get into next weekend, 4 feet at 13 seconds. San Diego possibly picking up on some of the energy too. Surf heights in the 3 feet later on Monday, dropping to 2.5 feet on Tuesday, 2 feet on Wednesday, and then picking up a little bit on Thursday in the 3 foot range, fading from there, maybe 2.5 feet as we get later into Sunday, a week from now. Swell heights, 2 feet on Monday, building to 2 feet at 16 seconds on Monday, 1.5 feet, 14 seconds on Tuesday. You can see that. And then a little bit more energy, 2 to 2.5 feet on Friday, fading on Saturday, and back up to 1.8 feet at 14 to 15 seconds on Sunday. The North Shore of Oahu, where all the action will be because everything's aimed directly at them, assuming winds are tolerable. That might be the issue. Anyway, current swell fading in the Hawaiian Islands. As we get into Monday, surf picks up 20-foot surf on late Monday evening, fading from 15 feet on Tuesday, down from there. Another pulse of energy on Thursday in the 15 to 18 foot range into maybe early Friday, then fading out from there. Trades blowing pretty good, 20 knots here as we get into the next weekend time. But for this, north winds on Monday at 15 knots, and then the next pulse of swell, northeast at 19 to 20 knots. Over to Ireland, Central Ireland, surf heights, in the 9 to 10 foot range sort of for the early part of the week, but big swell hits on Thursday, theoretically 30 foot faces. not counting swell enhancing bathymetry, with some sort of a southeast flow at 15 knots, if not south flow, which would be offshore at certain select locations, and then down into the 15-foot range with some sort of south to southeasterly flow on Sunday. Oh, and swell heights. Let's go take a look at 18 feet at 17 seconds. That is indeed long period swell at the peak, dropping down from there, and then 12 feet at 13 seconds, 9.5 feet at 15 seconds next Sunday. And one last stop, central Portugal. Pulse of swell on late Tuesday, early Wednesday. That's pretty much overnight. 18 feet dropping out, and then more energy on Friday in the 17 to 18 foot range into early Saturday, 22 sort of foot range, and then fading from there, but still not small. What's the wind situation? Oh, northwest 25 knots. I'm just picking each of the heights here. Northwest at 17 knots. Yeah, pretty much an onshore flow the whole time. All right, so the teaser part of the video, the title, a little bit of hype there, but now we're going to go take a look at the long-term outlook, focusing on the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation, the two major weather oscillations that affect our potential for surf and rain long-term. We're going to start by looking at trade wind patterns over the Equatorial Pacific. This is where all the magic happens, and this is how you can tell what is going on with the MJO, the Madden-Julian Oscillation. It is a periodic weather oscillation that rotates around the planet from west to east on the equator. The active phase of the MJO on one side of the planet, inactive phase of the other. They rotate around the planet opposite each other. The active phase of the MJO is like a low-pressure system. It takes warm, moist air at the ocean's surface, lifts it aloft. That energy feeds into the jet stream, making the jet stream stronger and more cohesive. Exactly what we see trying to happen over the Pacific, suggesting that the active phase of the MJO is trying to enter the West Pacific. The inactive phase of the MJO is like a high-pressure system. It creates dry, falling air. That air steals energy from the jet stream, makes the jet stream weak and split and incapable of supporting gale formation. Exactly what we had for the previous 3 or 4 weeks. But we can confirm all this by looking at trade winds. So this is data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. This is the East Pacific here, West Pacific here. That's New Guinea. The date line is right there. We're just looking at the arrows. They are indicative of what the winds are doing. The longer the arrow, the stronger the wind. So trades out of the east, moderate over the East Pacific, pretty strong over the Central Pacific, and then you get right here to about 170 east, and actual westerly winds are blowing. One day of that is not a big deal, but if it persists for many days, that is what is known as a westerly wind burst. And it's not just the west winds, it actually has to manifest as westerly anomalies. Exactly what we have here. The difference from normal for this time of year. So you go in the east here and you see, yeah, we have east trades, but 0 arrows suggesting those trades are exactly normal for this time of year. Trades a little bit stronger here over the Central Pacific, making it to right about here. Again, that like 175 east area. And then over here, literal westerly anomalies blowing, if not westerly winds. This is, again, if it's going to continue, and it actually has been going on for about 4 or 5 days now at least, indicative of a building westerly wind burst. That is good for transporting warm water on the equator in the West Pacific to the east. That can create a thing called a Kelvin wave, a ball of warm water that pushes east. We haven't talked about this in, 2 years, 3 years. We're finally at a point where I said, OMG, I kind of meant it. I was hyping it a little bit, but it kind of is as we get into this, you'll see it's kind of almost potentially exciting. Let's go look at what winds have been doing over the past 5 days. 850 millibar wind anomalies. Are the winds blowing stronger than normal or weaker than normal? Trades, That would be, and this is only on the equator. So 0 is the equator. There's South America, Central America, New Guinea there, the date line right there, the equator right there. And it's really in the West Pacific where this matters. And you see literal westerly anomalies, and pretty strong here, almost on the date line. This was on January 5th. The same thing, westerly wind pattern the whole way over the entire Western Pacific on the 6th, fading a little on the 7th, 8th, and 9th. But not out. And then you get to the forecast. We're not going there yet, but there is yet more forecast. Next up, an outgoing long wave radiation forecast. What's that mean? It's just showing how much sunlight is reflecting off the ocean's surface as compared to normal. If you have the active phase of the MJO, it is taking warm, moist air and lifting it aloft. That warm, moist air condenses, creates more clouds than normal, and you get less sunlight reflecting off the ocean surface. Negative anomalies, the blues. So this would be the active phase of the MJO, and the inactive phase would be more sunlight reflecting off the ocean surface, positive anomalies, and South America, Central America, New Guinea, the equator running right along there, and Africa over here. So you see in the West Pacific, it looks like the active phase of the MJO is already set up. And this, per the statistic model, has it pushing across the Pacific to past the date line. This is 5 days, so 5 days, 10 days, 15 days from now, with the inactive phase building over the maritime continent. This is a statistic model. The dynamic model, much more positive, suggests a very slow build of the active phase into strong status and still over the West Pacific 2 weeks from now. That would be very good. Phase diagrams for those same two models. What is a phase diagram? It just shows you where the core of the active phase of the MJO is around the planet and how strong it is. So the MJO moves from west to east, from the Indian Ocean to the maritime continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. They literally rotate around the planet continuously. The heavy dot is where the active phase is. The further the dot is from the circle, the stronger it is. So a very weak active phase today. 1, 2, 3 different versions of the model have it over Africa 2 weeks from now, and either very weak or maybe modest in strength. The dynamic model, completely different story here, suggests the active phase building the further away from that circle, right there, the stronger. So moderate to almost weakly strong, and this would be each dot's a day, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 days from now over the West Pacific, moving to the East Pacific 15 days from now. So something to keep our eye on, and I would tend to trust the dynamic model more than the statistic model. That's just my perspective, having done this for a while. And then here is the 850 millibar zonal wind anomaly forecast for the next 2 weeks from the GFS model. All right. The blues are easterly anomalies. That would be stronger than normal trades. The yellows and the reds, westerly anomalies, suppressed trades. Now, this is for the whole planet, so let's get ourselves oriented. The date line right here, 180. Far West Pacific starts at 125 east, so right there. And you see this is easterly anomalies in that zone up until about, 5 or 6 days ago, and then the easterly anomalies dissipated. Westerly anomalies started building. Look what happens 2 days from now. Strong westerly anomalies set up, filling everywhere, almost from the date line to the far West Pacific. Now think about this. The jet stream is flowing from west to east. It's going to flow right over this area. That area is uplifting warm, moist air. That will supercharge the jet stream and help pour energy into it, making it stronger, better for digging out troughs and building surf, at least according to this. Okay, this model goes out 2 weeks. Again, the caveat, do not necessarily trust a model going 2 weeks out, but this has been on the GFS model. I think it was even some rough flavor of it was on 10 days ago when we did our last video. So it's there. It was a little bit stronger 2 days ago. The intensity of this has been vacillating, but it's been here consistently for a good long time now. This is a very good sign and indicates a much better pattern for storm production in the greater Pacific in the weeks to come. Then we go to the CFS model, okay, a different dynamic model, but it's sort of saying the same thing. And this is 1 day behind, but the date line again, right up the middle of the chart here. Far West Pacific starts at 125 east. The MJO is actually indicated here with the solid contour, and an equatorial Rossby wave pattern is the reds. So here is where we were back in November and December. The dotted contour, inactive phase of the MJO, easterly anomalies in control the whole time over Christmas. And then we got to the new year somewhere right about here. You see the active phase of the MJO starting to nose into the West Pacific. We also had an interaction with the equatorial Rossby wave, creating westerly anomalies. So we're really just now starting to get into the true active phase of the MJO with the second contour developing, pushing across to about the date line, just shy of there through the end of the month. And westerly anomalies, here's your scale. I think this is 9 meters per second or more, about as strong as it can get, forecast starting 3 days from now, the whole way through to almost the end of January. This would dump major amounts of fuel into the jet stream, helping to support storm development. And then we have the CFS model going out 3 months. That's up here. Past performance is on the bottom. Date line runs right up the middle here. Far West Pacific starts at 125 east, so right here. Here was our last active phase of the MJO back in October and November. Yeah, we had surf. It was good. Then the inactive phase set up right about the beginning of December. Easterly anomalies set up over the West Pacific, and our storm machine just completely fell apart. Here we are today, actually the January 11th. Inactive phase, yeah, a little bit hanging on for about another week, but it's already pushing out with westerly anomalies in the next 2 days. Forecast building to strong status over the far West Pacific. You see the active phase holding on the date line into about February 15th, the middle of February, with westerly anomalies in control that entire time. Inactive phase builds after that, starting about the beginning of February, but westerly anomalies hold on the whole way through that, and then another active phase past that into April. The really key thing to look here is, I'm going to pull that away. Here's the pattern. Dominated by easterly anomalies up to about today, and then you see nothing but westerly anomalies from here forward. Perhaps the long-awaited change that we have been looking for. The other thing to notice here is westerly anomalies were over the maritime continent here at 90 east to 120 east. Starting today, easterly anomalies building over Australia, that area. I mean, so we'd be looking to verify this by reports of droughts and maybe wildfires in Australia, that area, while we also would see more precipitation than normal over New Guinea out towards somewhere around the dateline area, maybe Christmas Island. We don't get much reports from there, but this would be something. Okay, anyway, you get the idea. We'll overlay that. And then on top of that, the low pass filter. This is the El Nino La Nina indicator. The dotted contour, a high pressure bias. This would be La Nina in control, but you see starting 2 weeks from now, it starts crashing, while the low pressure bias, again, 2 weeks from now, starts easing. Well, it's already in the West Pacific at about 145, 150 east, but it's supposed to start moving in earnest as we get into February, the whole way over the date line, if not beyond, with a second contour setting up as we get into March. Okay, So let's talk about El Nino for a minute. The typical way that El Nino starts, especially stronger El Ninos, is you start seeing them in January or February, a whole year before El Nino actually manifests itself. And it typically starts by, one, lower pressure building over the Pacific. We've been talking about this for years now. Too much high pressure over the Pacific. All of a sudden, indications that maybe low pressure is going to start building. Second, you see the development of westerly anomalies over the West Pacific, and more specifically, westerly wind bursts, just like this right here. One does not mean a whole lot. But if we get 2 or 3, and we'll have to see what happens. I mean, we're talking months out here. But if we get another one or a third one, that would be a very good sign. This same thing sort of happened in the build-up to the El Nino that turned out to be kind of a dud in 22, 23. But it was in January. It was actually in December. We got a westerly wind burst. The rain started, and it just didn't stop, and we got piles of snow and all that. That was the run-up to a weak El Nino. Same sort of thing maybe is trying here. I'm probably definitely overhyping it here, because all we're going to have right now on the books or on the charts is reasonably one westerly wind burst. But we're going to look for more of them. We're going to look for this low pressure bias building over the Pacific, because all that does is just starts dumping energy into the jet stream. The jet stream starts falling further south. The further south it gets, that's an indication of how strong it is, but that also, if it has enough momentum behind it, can start pushing into California. Then you start getting those atmospheric river events, more rain, more precip than normal. I'm not saying that's coming, but we're going to keep our eyes on it. The next piece of the puzzle that we would be monitoring is subsurface water temperatures down. They call it the thermocline, down 150 meters down. So that'd be right here. This is the West Pacific. This is the East Pacific. These lines right here are the anchor lines on the TAO buoys strung the whole way across the equator, across the Pacific on the equator. The X's are sensors on those anchor lines. They give us an idea of what's going on subsurface temperature-wise. Why does that matter? Well, if you have, in the West Pacific here, if you have westerly winds blowing here, they will take warm water that's normally sequestered here, driven by trades blowing the whole from east to west the whole way across the Pacific. If the trades collapse, the warm water starts moving east, but it doesn't move east on the surface. It does it down at the thermocline level, down 150 meters down. So I'm looking for the 30 degree isotherm. I don't see it here. It was there last week. The 29 degree isotherm is about where it was last week. The 28 degree isotherm, it's been toggling right about here, suggesting the trades and the westerly winds are in some sort of, there is a dividing line. We saw it on the charts. It's somewhere right around here. And we want to see this water starting to move east. The 24 degree isotherm, it was back at 115, I think, at some point a couple of days ago. It has retrograded a little bit. But it is not actual temperatures that matters. It is the anomalies, the difference from normal for this time of year. We see 3 degree above normal temperatures here in the West Pacific. Where is the leading edge of this? I think that's 150, 140. There is this finger making it to 125 even. That is indicative of warm water pushing off to the east, but there's still this kind of cool pocket sitting right here. You want to see all of this pushing off in here, and we're not seeing it according to this. And we still have this pocket of cooler water here to be expected. That's actually pretty normal. But then we have the same data amplified by satellite imagery. So this is the subsurface temperature data. Thermocline right here at 150. Now look at this. It suggests warm water pushing the whole way to 110 west. Clearly, not just a little finger. Well, in fact, maybe we can show it. Not just that little finger, but all this area is filled in this image. This suggests we already have a Kelvin wave in flight, not from the current westerly anomalies, but from the westerly anomalies back in November, okay? So literally, 1 Kelvin wave in flight, and we know we have a significant westerly wind burst forecast, if not developing right now, perhaps a 2nd Kelvin wave developing behind this. It takes, I think it's 3 to 4 months for a Kelvin wave to go from the far West Pacific erupting into Ecuador. So the next thing you want to be looking for is these blues here getting smaller and smaller and fading. And then at some point, our friends that live in Ecuador, and some of them literally comment on the in the comment section of our videos, providing us status of what is actually happening down there. And typically, you would see warmer than normal water, and then they would start reporting, hey, it's getting cloudier, hey, it's raining more than normal for this time of year too. Again, anecdotal information, but still another piece of the puzzle that we can all monitor real time. Here is the satellite data used to amplify that previous chart. This is showing you not temperatures, but showing you the height of the ocean surface. That is, take away the wind waves, the swell, the tides, and is the sphere of the ocean higher or lower than normal? Why does that matter? Well, if you have cold water at depth, cold water contracts. Above it, you get a divot on the ocean surface. Warm water expands. It'll push your ocean surface up. Okay, so what are we looking at? So the equator right here, date line out here. This would be Chile, Peru, Ecuador there. That is the Galapagos. There's Central America. New Guinea right there. Entrance to the far West Pacific, where does it have it here? 120 east. Yeah, there's the islands there. So about 125 east. You see warm water or positive sea height anomalies indicative of warm water pushing to the date line. But what we also see here, that little finger pushing across right here, that wasn't here at all. There were a couple little pockets of neutral water temperatures. Now we have pockets of slightly above water temperatures reaching to, again, 110 west. Is this believable? It seems like it is, but we'll have to keep monitoring the situation. If this is true, it suggests a Kelvin wave is in flight. Let's see how far across the Pacific it makes it. And then finally, upper ocean heat anomalies. This sort of puts it all together and puts it in time. West Pacific here, East Pacific here. This goes back a year, so January 2025, here we are, January 2026. The reds and the oranges, warmer than normal temperatures. So here was last year's Modoki La Nina. Here's our current La Nina. Well, what is left of it? You see the only cool water left is at 105. The official El Nino monitoring region is from 120 west, 5 degrees north and south of the equator, out to 170 west. And if you look at this, there is warmer than normal water temperatures, a half a degree, let's say, the whole way across, filling the Nino 3.4 region. And this is not a model. This is not a projection. This is literally what is happening right now. This updates every 5 days. So in the past 5 days, it looks like at least that finger of warming water temperature. Now, again, that is driven by the satellite data mainly. The buoy data doesn't support it nearly as strongly, but it suggests a good amount of warm water is spilling over the dateline into the East Pacific, indicative of a Kelvin wave pushing east. Hooray. So the subsurface temperature profile tells us what is to come, but it is what is happening at the surface that is in total contradiction to that. South America, Central America, New Guinea, the equator, the dateline, blues, colder than normal temperatures from the Galapagos the whole way out to the dateline, a little bit beyond. The official El Nino monitoring, 170 west to 120 west, right in there, 5 degrees north and south of the equator, all suggesting cooler than normal waters. So what's this mean? It says we have La Nina at the surface. And again, the cooler water on the ocean surface prevents evaporation, prevents lifting air, supports sinking air, supports high pressure, which is the hallmark of La Nina. So at the surface, the ocean is saying La Nina, but looking down under the ocean surface, we see warm water, and not a little bit, a whole flow of warm water making it to 110 west underneath this warm pool. As soon as that this cool pool, as soon as that warm pool hits Ecuador and the Galapagos Islands, it's going to start gurgling to the surface. The trade winds will take it and start backfilling it over this area. And if our theory is correct, you will see these temperatures start to warm significantly and rather quickly. The 7-day trend is just, it's not indicative of a whole lot, but South America, Ecuador, the Galapagos, look at the water temperatures here. They've warmed significantly just over the past 7 days and starting to work their way out to 120 west. Again, the official El Nino monitoring region is out here. So this is Nino 1.2, the early warning sort of symbol. As Kelvin waves start sloshing into here, then they bounce off the coast and they're sequestered right along the equator. You have high pressure here circulating like that, high pressure here circulating like that. But these Kelvin waves push right under this line, under the ocean surface, hit the coast here, bounce off, and then start radiating this way. This is a very good sign, if nothing else, suggesting trades are weaker than normal in this area and the sun is warming the ocean surface. I don't think we have actual upwelling from the Kelvin wave yet because the leading edge of it is out here and it's still down pretty far, down 100 to 150 meters. Sea surface temperature anomalies, not a forecast, actual data, the trend for the past couple of months. Current value right here. Temperatures 659 thousandths of a degree below normal, okay? But you see the definite warming trend. We saw that in the last picture. Warming, neutral is up here, so we still have a ways to go. Again, cold water still at the surface, but we're moving in the right direction. We want to see movement up into here. The official El Nino monitoring region, the Nino 3.4 region, really going nowhere. It says minus 1.179 degrees, so still below normal. In the official El Nino monitoring region, half a degree above to half a degree below is considered normal. It varies there. From half to 1 degree is considered weak La Nina if it persists for like 5 months. And then from 1 to 1.5 degrees is moderate, medium, moderate La Nina. So we're there. But again, this data is not corrected. It doesn't account for the global warming signal. So we'll have to see how this all plays out. Corrected sea surface temperature data weekly. Here we go. This is the Nino 3.4 region. This is Nino 4. This is Nino 1.2. Current value, half a degree below normal. Where were we? 7/10, 8/10, 7/10. So weak La Nina. And 1 day does not a trend, or 1 week does not a trend make, but it looks like the temperatures are heading at least in the right direction. So what does the atmosphere think is going on? Well, we know we have cooler than normal water temperatures on the ocean surface, which doesn't support evaporation, which only supports high pressure. So one would expect that pressure in the Pacific is probably above normal. We look at the difference in pressure between Darwin, Australia, in the maritime continent, and Tahiti over the central Pacific. When pressure is lower in Tahiti, the index goes negative. Well, we're at plus 20.69, but we've only been there for 2 days. I mean, there's a lot of some little high pressure system can sit over Tahiti for a day or two and just skew this data wildly. So you can see, we'll just go back here. Yeah, generally it's been positive. Here was our negatives. Oh, that was even in December. So generally positive, but this is updated daily. The 30-day average, today's value 6.51. It's creeping up. Here was our active phase of the MJO probably back in November, but it's a 50 because it's 30-day average. It's a look back about 15 days. So pressure going up. The 90-day average 7.91. Where were we a month ago? 7.23. So pretty much unchanged. Weak La Nina territory. Let's look at a graph real quick. Here's the 30-day average right at, plus 7.1. The Bureau of Meteorology in Australia says plus 7 to minus 7 is pretty much neutral. We've been through a big inactive phase. This was our active phase of the MJO, falling data, or falling graph is the active phase, rising is the inactive phase. This was what was giving us our swell back in November. Here's what December did to us, kind of killed us. We would expect at some point, if these westerly anomalies are building and low pressure is building in the West Pacific, at some point this is going to turn around. But also remember, Tahiti is at 140 west, where all the action is that we're seeing on the charts in the West Pacific is on the date line 180 and points west of there. So we still probably have a couple of weeks. This is going to creep up while that active phase of the MJO pushes to the east, but at some point it's going to hit Tahiti, and all of a sudden this graph is going to fall off the chart. What is the sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region from the CFS version 2 model for the next 3 months? Let's just go for a couple of days even. All right, January, the 15th of January, the lines here, the months, it's the middle of the month. So there you go. Temperatures forecast at minus 0.65 of a degree. Neutral is from half a degree below to half a degree above. So you see pretty much starting, today's the 11th. So 4 days from now, we're here. And probably about another 4 days after that, we should see water temperatures starting to rise, which means that blue that we're seeing on the charts, the sea surface temperature anomalies, should all of a sudden start be getting a lighter shade of blue. And you see what happens by the time you're into January, February, middle of March, not even early March, late February, temperatures literally hit dead zero, completely neutral. And then you don't want to look here. I don't know whether any of that's believable or not. The CFS model, okay, I'll say it. I don't want to say it. I don't want to jinx it. But you can look at the graph and decide for yourself what the water temperatures are supposed to do in the Nino 3.4 region. And if it does as is forecast, that would be a good thing. And then finally, the Pacific Decadal Oscillation. This is another oscillation that rides, so we have the seasonal variation, right? And then embedded in that, you have the MJO that sort of wobbles things warmer or colder, or stronger trades or weaker trades. Then on top of that, you have the El Nino. It's like a 7-year oscillation. Once every 7 years, you get an El Nino, and then you get La Ninas, where things get cooler. And on top of that, there is the Pacific Decadal Oscillation. It's a 25 to 30-year cycle, again, running cold or hot. The graph pretty much says it right here. Cold, cold, cold. All these are negative anomalies. We were down to the coldest ever on record. I don't know if that really is meaningful. Minus 4.21. They even adjusted it downward after it happened. But notice, here we are in December, definitely working our way up -1, which isn't so bad. Now, let's put things in perspective. When was the last time we had a -1? Well, somewhere right around in January. Here's another February -1.3, another January -1.24. Where was the next January? Right there. That was pretty cold. There's another one out here. There you go, 0.6. You see we've been in this cooler pattern since pretty much 2017. We are rising up, but I'm not going to get over my skis here because it appears there is a seasonal component to this where things mellow out in January. Why would that be? Well, it's also in January where the MJO typically wakes up, does its thing for a couple of months, but if it falters, then you fall right back in the hole. So I'm not going to get excited and say, oh, this is an indication that we're going to move out of the cold phase of the PDO or anything like that. I think right now, I'm just going to say it's seasonal variation, but we will keep our eyes on it to see if it does transition from blue to some flavor of red over the next couple of months. Not holding my breath too long, but maybe. All right, so multiple things are interacting here all at the same time, but in general, it seems like it's for the better. One, we'll start with the near term. Multiple gales, forecast developing on the dateline, being driven by, and this is the important thing. The jet stream consolidating and getting stronger, which in turn is being fed that energy from the active phase of the MJO, which is in turn generating westerly anomalies, pumping that energy up into the jet stream. So all this is connected. And the same thing happened back in November. Active phase of the MJO fed energy to the jet stream. We got a series of storms. Not great surf, but we had surf. But even more so, because it dampened the trade winds in the West Pacific, it set up a Kelvin wave, warm water pushing off to the east. And that warm water we see now is at 110 west, poised to make it to the Galapagos and Ecuador. And it seems like it's real. We'll see what happens. We got to monitor all this. But if that's one Kelvin wave, and then per the CFS model and the GFS model, major westerly wind burst is forecast over the coming weeks to next month. That could create another Kelvin wave that would totally wipe out all the cold water on the ocean surface on the equator, eliminating El Nino in the dead of winter, possibly setting us up for something better. Not so much, the westerly wind burst will feed the jet stream, which will make storm development for a good portion of this winter. I don't think the warm water thing is going to do anything in terms of feeding storm development. It's going to be probably months out for that to have an effect. We'll be in the middle of spring moving to summer before the warm water pattern starts setting up, if it does set up. But that could mean good things for the summer to come, because the jet stream, both north and south, will pick up on it eventually. It takes about 3 months, right? We don't even have warm water on the ocean surface yet. It has to get on the surface. Then it takes 3 months before the jet stream will respond to it in kind. But it seems like the fundamentals, the pieces for a feedback loop are starting to move into place. Now, what about rain for California and the Pacific Northwest? Yes, high pressure is in control. We're in the inactive phase of the MJO. I think that's going to fade, but it might be another 4 weeks or something like that. So the snow machine might not come back until we get into February sometime. We knew we were in La Nina. It was advertised all last summer. So this should be no big shocker. Oh, it's dry. Oh, where's my snow? If you've been following the videos, you have been informed, and you know from following the charts yourself. So, but I do suspect as the active phase of the MJO pushes the jet stream, it's going to push itself across from west to east, and at some point it's going to be south of California. That will drive the jet stream south in probably, mid-February, just guessing here. Maybe before that, early February, the rain will start again, and then we'll get opportunity for snow. I didn't go into all the details about where we are rain-wise, but right now we're doing really good for this time of the year, but we're only really getting into the heart of the rainy season now. All right, so all in all, things looking pretty good. If you enjoyed the video, please give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a question, which would not be surprising given all that we've covered, write it up down below. I'd be happy to respond. And if you'd like to leave a small contribution to the cause, you may. Hit the super thanks button down below, the heart with the $sign in it. Many thanks again to all the folks that have donated this week, and for that matter, over the entire year. It is greatly appreciated. There are costs required, not so much to do these videos, but certainly to keep the website running, and that's really where all the money goes. It is to pay for the servers, pay for the comm lines, and it's a constant game of whack-a-mole where Noah's changing stuff and things happen, and so there's coding efforts required, and I have people that I pay to help me do some of this stuff too. So your contributions are greatly appreciated. And with that, we are done for this week. We'll do it again next week, same time, same channel. Thanks so much for watching.